Hello and welcome to another chemistry lesson. In this lesson I'm going to have a look at types of reactions, which refers to looking at the reaction equations and deciding what type of reaction it is. And I think it would be best if I just go ahead and explain the 5 types that I'm going to look at. There are many more than just 5. These are the 5 basic ones, and when it comes to organic chemistry, as well as some other fields of chemistry, we will look at more types of reactions, but for now this will suffice. Okay, the first is called synthesis. Okay, a synthesis reaction, if you didn't know, synthesize means to create, to make a replica, or for example, synthetic material is a replication of a certain material. So synthesis is when I have two reactants, and those reactants produce a single product. Okay, so that is how you will recognize a synthesis reaction. Okay, so we've got 2 reactants and a single product. Okay, so let me show you an example. The example that we've looked at numerous times is sodium plus chlorine producing sodium chloride or table salt. Okay, and we had to balance this by doing it like this. Okay, is the balanced reaction for a balanced synthesis reaction. The next one is a decomposition reaction. Okay, decomposition. I think my spelling is correct. Okay, in a decomposition is exactly the opposite. A decomposition reaction is when I have a compound, okay, or if I have a single product and it is broken up into 2 or more compounds, or at least 2 or more products. Okay, so that's the exact opposite of this, and that's decomposition. When something decomposes, it breaks up, so it makes sense. Decomposition is a single reactant breaking up into 2 or more, and I should have said it here, it can be 2 or more reactants. Okay, and this time it produces 2 or more products. One example would be hydrogen peroxide, H2O2. Okay, this is not water, it's called hydrogen peroxide, and it can decompose into hydrogen plus oxygen, and this is already a balanced equation. That's an example of a decomposition reaction. Okay, the next one I'm going to have a look at is called single replacement. Okay, in a single replacement, okay, I will have an element, okay, that means a single plus a compound, and it will produce a different compound, let's say a C, plus a different element. Okay, so when I say different, I don't mean it's completely new molecules or completely new elements. Of course it's not. Okay, what it just means is that in the compound, a compound means it's 2 or more elements together. The original or the reactants have an element and a compound, and in the products we have a different element. Okay, so the compound has somehow been replaced. One of the elements have been replaced by the element here and produced a compound there. Okay, if I do an example, you'll see exactly what I mean if this has been a bit confusing. So, for example, if I were to dissolve zinc in hydrochloric acid, HCl, it will produce zinc chloride plus hydrogen gas. Okay, so if I should just balance this equation, and then we can see there should be two of these, since there's two H's this side, two Cl's that side. So there we go. Okay, so again, notice that I had my element and my compound, and here I've got my compound and my element, and here you can see that it looks as if the zinc had replaced the the hydrogen, so that now it's zinc and chloride instead of hydrogen and chloride, and instead of the element zinc, it is the element hydrogen. Okay, single replacement, easy enough, I'm sure. Okay, then double replacement. In a double replacement, I would have two compounds, A, B plus C, D, in my reactants, and in my products, I will have two different. Okay, I would have AD plus CB. I will have two different ones, and so it looks like A replaced C to be AD, and it looks like B replaced D to come C. B. It looked like, yeah, B replaced D, yes, to become CB. Sorry. Okay, if I were to look at an example, if we took sodium, let me just use a different color to distinguish it. If we used sodium chloride and mixed it with silver nitrate. Okay, now notice here that this produces a new one. It produces silver chloride plus sodium silver chloride plus sodium nitrate. And this is then an example of double replacement. Let me show you the double replacement. Okay, so here comes into play what we call an ion, or rather an ionic compound, and that is this nitrate here. This is called nitrate. Okay, and we are going to consider this nitrate as a compound or an ion by itself. Okay, so if I have that as the one and this is the other, that as one and this is the other, notice how the nitrate replaces the silver to become, sorry, the sodium replaces the silver to become sodium nitrate instead of silver nitrate, and the silver replaces the sodium to become silver chloride instead of sodium chloride. Okay, we have a double replacement in this case. In a future video, I will look at some of these ionic compounds and just explain a little bit more about that, so that you don't feel intimidated as I was when I originally encountered them. Okay, that is now the double replacement, and now final one is combustion, a combustion reaction. Combustion is exactly what it sounds. It sounds like something exploding. That's exactly what it is. Combustion reactions happen when we have some sort of hydrocarbon. This is what this is called. Hydrocarbon means there's a certain number of carbons, a certain number of hydrogens. That's why it's hydrocarbons. And you see the Hill system coming into play here. Okay, and then certain number of carbons, a certain number of hydrogens interacting with oxygen. Okay, and for any explosion we always need oxygen. That's why we will have that, and in the end we will have whatever plus H2O plus CO2. So in a combustion reaction, there might be more products on the left hand side, so let me do that. Okay, but we will always have some carbon hydrogen compound. We will always have oxygen. That must be on the left hand side. On the right hand side we must have both water as well as carbon dioxide, and this will be a combustion reaction. And yeah, let me give you an example. Let's take the combustion of methane. That's methane plus O2 combusts to give me exactly this 2H2. Well, let me do this first and then I'll balance it. It will produce H2O plus CO2, and let's balance this equation. Okay, let's start with the element that is only represented once on either side, which is hydrogen, or let's go for carbon. Okay, so there's one carbon on both sides, so that's fine. Hydrogen, there's 4 on this side, so we're going to have to multiply with a 2 here, okay, to give me 4 hydrogens. And now since I've got that sorted, I can now go to the carbons again, and I see now I've got 1 carbon here, 1 carbon there. That's fine. Okay, and then I can go to my oxygens. I've got 2 oxygens here and another 2 oxygens there, making it 4 oxygens. So I'll have to put a full, sorry, not a 4 there, it's already 2, I need to put a 2 there, and there I've balanced that equation. Excellent. This is combustion reactions, and these are the 5 different types of the reactions that we will look at, but there are many more, and they will come up along as we go along. Thank you very much for watching. I hope you learned something.